Hi, my name is Sebastian Darrington from the RecoverPoint Specialist Salesforce. We're going to spend the next 20 minutes just looking at the administration and operation of RecoverPoint. Two ways of administrating RecoverPoint, either via a CLI, or in this case, we're going to utilize the RecoverPoint GUI. So we're going to log into the RecoverPoint GUI. The GUI is in fact a Java applet. You connect to a clustered IP address of the RecoverPoint appliances, and you're able to launch the RecoverPoint GUI, as we can see it here. Within the RecoverPoint GUI itself, we can see in the top right-hand corner, effectively our site layout. So in this case, we're replicating bidirectionally between New York and London. There's three primary components to a RecoverPoint solution, which we'll talk through. The RecoverPoint appliances themselves. These appliances are out of band. The RecoverPoint appliances are doing a number of different things, including FCIP, compression, and replication. Because these appliances are out of band, we need a method of capturing the ongoing write I/O. So to do that, we have three what we call splitter technologies. There's either a host-based splitter, which is an agent that sits on the host, supports Windows, Solaris, and AIX, captures the application write I/O as it leaves the host. There's a fabric-based splitter, which supports specific hardware from Cisco or Brocade. In this case, as the writes pass through the switch layer, the switches take a copy of those writes and send them to the RecoverPoint appliances for replication. Or there's what we call the Clarion splitter. So built onto the Clarion storage arrays, NS, Clarion, or VNX, there is the ability to capture the ongoing write I/O and send that to the RecoverPoint appliances for replication also. In the top left-hand corner, we can see our system traffic. So the blue line is the incoming write I/O being captured by the splitter technologies and sent to the RecoverPoint appliances. And the green line is what we're currently replicating over the WAN. So one of the unique benefits of RecoverPoint, as well as its granular recovery capability, is that we get very good compression with RecoverPoints. So on average, we kind of see 5:1, 6:1 compression ratios. If you compare that with a standard-based replication solution where you're maybe getting 1:1 or 2:1 compression, it does mean that we can utilize RecoverPoint with 3 times less bandwidth whilst maintaining similar RPO and RTOs to those technologies that require more bandwidth in this case. We're going to start at the bottom and we're going to work our way up. So full logging capability with RecoverPoint, log to the GUI as we can see here. We also have full SNMP trapping, so we can send SNMP alerts to a high level framework as required from a customer perspective. Also full email alerting, so we can send different levels of alerts to different people based on the information that they require. Just whilst we're here, we'll talk quickly about the RecoverPoint user settings. So RecoverPoint is LDAP integrated. This means we can import users from such things as Active Directory. And we have very good roles-based permissions within RecoverPoint. So we can literally define on a per consistency group basis the different tasks that a user is able to perform on that consistency group or across consistency groups. Next tab up is my system monitoring tab. So in the system monitoring tab, I get a very clear overview of the health of my RecoverPoint system against such things as the licensed capacity. So here I can see the number of hosts that I'm currently utilizing from a host-based splitter perspective. I can see both my local capacity replicated license and also my remote replication license, so my CDP and my CRR. And I can see, as an example, the number of distributed consistency groups that I currently have running in my RecoverPoint cluster. The next tab up is my vCenter server tab. One of the things that we can do with RecoverPoint is that we've got very good affinity into VMware. So we fully support things like Site Recovery Manager. RecoverPoint is a site replication adapter for Site Recovery Manager, which means you can automatically fail at the push of a button your virtual machine infrastructure to the remote site. And Site Recovery Manager will automatically choose the latest point in time from RecoverPoint, reverse the replication direction, as an example. One of the other things that we do is that we have very good affinity from a vCenter perspective. So we can actually poll the vCenter servers, look at the virtual machines that are running on those vCenter servers, look at the LUNs that those virtual machines are running on, and correlate that back to the LUNs that we're actually replicating within RecoverPoint. As a result, we can see on a per virtual machine basis whether those virtual machines are protected or not. That polling happens at a regular interval. So if you were to do a storage vMotion of a virtual machine from a protected LUN to a non-RecoverPoint protected LUN, you get alerted to the fact that that virtual machine is no longer protected. The next tab up is my volumes tab. In my volumes tab, I can see 3 different types of volume. So there's a replication type. This is a source or target LUN utilized within the RecoverPoint consistency group. There's a journal LUN, which we'll talk about later, but the journal LUN is where we're keeping the historical block-based information that gives us our granular recovery capability within RecoverPoint. And then there's a repository volume. The repository volume is effectively a quorum resource for the RecoverPoint cluster. Maximum required size of that is roughly about 6 gig, 1 LUN per site per RecoverPoint cluster. My next tab up are my RecoverPoint appliances. So with RecoverPoint, you can have up to 8 appliances in a RecoverPoint cluster. The minimum is 2 appliances for high availability. It's an active-active cluster with consistency groups distributed across the available RecoverPoint appliances. In the event that you lose an appliance, the remaining appliances will take over the load of any consistency groups that were running on the failed appliance. So a minimum of 2, maximum of 8. In this case, I can see the full 8 appliances per site. If I double click an appliance, I can actually see what's actually happening from an application traffic and total traffic perspective within that appliance. This information is important because today you manually load balance RecoverPoint consistency groups across appliances. So this gives you a view of which appliances are underutilized so that you can actually move your consistency groups around. So at this point in time, we're going to go and add a new Clarion splitter, which we're going to utilize later on. So I click the Add Splitter button. I can see a number of different splitter technologies that have been registered with RecoverPoint appliances. I'm going to add the Clarion splitter 2A and B both in London and New York. So I'm going to choose the Clarion SPA in London. I'm also going to choose the Clarion SPA in New York. This will actually automatically add SPB as well. At this point in time, we're not going to configure the login credentials. So I can see my 2 splitters, my 2 Clarions, one in New York, one in London, and click Finish there. We'll see those splitters will get added into our GUI. And later on, when we create a consistency group, we'll utilize those splitters. So let's click on the consistency groups. So I can see I've got a number of pre-configured consistency groups. A consistency group is a collection of LUNs that you want to recover back to exactly the same point in time. How you create those consistency groups is completely up to you. So in this case, I've got a number of pre-configured groups. I can see here I've got an exchange consistency group. This exchange consistency group is replicating from London to New York. This is remote replication, so what we call continuous remote replication, CRR. I have another group here, a SQL group. This SQL group is doing a combination of both CDP and CRR. So with CDP, I'm able to maintain a full synchronous local copy or mirror of my data with the ability to recover back to any single write, which is what's occurring in New York. In addition, I'm also maintaining a full asynchronous copy of the data utilizing RecoverPoint CRR, in this case in London. So I'm taking one copy of that application write IO and I'm utilizing that to see both a CDP copy and a CRR copy, utilizing that single application write IO. As well as disaster recovery, RecoverPoint gets used heavily by our customers for operational recovery. The reason for that is RecoverPoint provides a very granular recovery capability, which is far more convenient than having to roll back to a tape backup maybe 24 hours ago and therefore sustain a lot more data loss. However, from a consistency group configuration point of view, the requirements for operational recovery versus disaster recovery are actually very different. In an operational recovery scenario, you want very granular consistency groups, which maybe consist of a single database instance or a single exchange information store, so that you can recover those components individually. In a disaster recovery scenario, what you actually want to be able to do is recover back complete business applications. And in this case, a business application may actually be formed of multiple components. So maybe it's a SAP infrastructure with my database instances and my application instances. Maybe it's a SharePoint application with my underlying database, my SharePoint application, my web applications that interface into that. In those kind of disaster recovery scenarios, what you want to be able to do is recover back all of those components back to exactly the same point in time. So from a RecoverPoint perspective, what we've enabled is both consistency groups to give you the individual instance of granularity for recovery, but we also have what we call group sets. And a group set is a collection of consistency groups that you want to be able to recover back to exactly the same point in time. So in this case, I could create a new consistency group. Within that, I could have my SQL and my ERP. So we'll call this group set 1. You can define the frequency in which you want to take those or define those bookmarks across those consistency groups, either in minutes or seconds. We're going to create a point in time every 10 minutes. And what this will do is, within both the SQL and the ERP consistency group, define a consistent point in time every 10 minutes across those groups. So that in the event of a disaster, I have the ability to recover those groups back to exactly the same point in time, and therefore get a granular and consistent recovery across those consistency groups. So at this point, what we're going to do is we're going to create a new consistency group to give you an idea of kind of the administration involved. So to do this, I click on Add Group. We're going to pretend that we've got an Oracle database that I actually want to create a consistency group for. So we're going to call this group Oracle. Number of different options. So the first thing is you define which of your appliances you want this consistency group to run on by default. So obviously in this case I've got 8 appliances. I could have gone and had a look which one was doing the least amount of work, and I can place my consistency group on that RecoverPoint appliance. In this case we're going to stay with RecoverPoint appliance 1. With RecoverPoint, I mentioned the bandwidth compression capabilities. So with RecoverPoint, we can compress the replication traffic that's being sent across the WAN. So you can either turn compression on or off. If compression's turned on, we have a sliding scale from best performance to best compression. Best performance for us in this case is minimizing the lag at the remote site. So we'll replicate the data as quickly as we possibly can do across to the remote site. Whereas best compression, what we're actually saying is kind of the reverse of best lag or best performance. What I want to do is collect more data locally within my RecoverPoint appliances so that I can get a better compare and a better compression. Obviously, this adversely affects your lag, which in this case would then increase. So you can have a sliding scale that best meets the SLA of that application. I click on my protection tab. So from a protection perspective, I've got my local CDP link, and I've also got my remote CRR link. With RecoverPoint, we can do both asynchronous and synchronous replication. In my asynchronous configuration, I'm able to define the maximum amount of lag that I wish RecoverPoint to sustain at the remote site. So I can define that in a number of different ways, whether it be capacity-based or time-based. There is a default system-optimized lag setting. What this will do is RecoverPoint will maintain the remote site as close to the local site as it possibly can do. I can also minimize the amount of bandwidth utilized by a consistency group. So in this case, I can say for my Oracle consistency group, I only want to utilize, as an example, 5 megabits per second of my available bandwidth. You're also able to do synchronous replication. Synchronous replication within RecoverPoint is slightly different from the normal synchronous replication. We have the option to do dynamic synchronous replication. Dynamic synchronous replication effectively enables you to set a high and low watermark where RecoverPoint will dynamically skip from synchronous replication back to asynchronous replication to reduce the impact on your primary applications of having to wait for a write acknowledgement. So in this case, I can set it either dynamic by latency or dynamic by throughput, and I can define different factors based on what I'm trying to achieve. Not every customer will want to set this setting, but for many customers who want the best that they possibly can do based on the bandwidth that they have available, synchronous or dynamic synchronous replication allows you for the majority of the time to achieve synchronous replication. And for those points during the working day where you can't, RecoverPoint will dynamically switch to an asynchronous mode, therefore reducing any impact on those primary application servers. And then finally, in my Advanced tab, I can set a number of different settings, including the ability to distribute consistency groups across a number of appliances. So today, a RecoverPoint appliance is able to sustain about 80 megabytes per second of sustained write I/O from an application. If a consistency group is running on a single appliance, obviously this means that the maximum support from a write I/O perspective that we can offer for that application is 80 megabytes per second. With the distribute group option, what we're able to do is distribute a single consistency group across multiple appliances, so that for each appliance that we add, we gain in terms of the maximum amount of write I/O that we're able to sustain for that application, and we can aggregate that across multiple RecoverPoint appliances. So at this point, we're going to stick with our default policy. We're going to click Next. RecoverPoint is bidirectional on a per consistency group basis. So I now choose which is my production site. So we're going to stick with New York. So we're going to call this Oracle Prod. Again, a number of advanced functionalities and settings that I can set within my RecoverPoint configuration, including the host type for that particular consistency group. Click Next. Now I decide whether I want both a local and or a remote copy. So this is CDP and CRR. In this case, we're just going to create a remote copy. So I'm going to call this Oracle CRR. Click Next. And now I need to build my replication sets. So a consistency group is built up of a replication set, and a replication set is simply a source and a target LUN. So I can see in New York, I have a number of volumes that are available to RecoverPoint. So this list gets populated by effectively exposing the production LUNs that you want to replicate to the RecoverPoint appliances. So as an example, within the Clarion, you create a new storage group. You add the HBAs of the RecoverPoint appliances, the worldwide names, into the storage group. And then like you would do if you were creating an application cluster, you assign the LUNs that you want to replicate to the RecoverPoint storage group as well as the host-based storage group. Doing so will then populate this list. So in this case, I can see a number of LUNs that are available across a number of different storage arrays. So I'm going to choose this 110 gig LUN on the CX320 as one of the LUNs that I want to replicate. So this as an example could be my database LUN. I've also got a 126 gig LUN here, which is potentially my log LUN for this Oracle instance that I want to replicate. I'm going to click Next. It's now going to take me to London, and it's going to show me the volumes that are available to the RecoverPoint cluster in London. So at this point, I'm going to choose a LUN that's the same size or larger as the primary LUN. So I can see my primary LUN in this case is the 110 gig LUN. So I'm going to choose a corresponding 110 gig LUN in London. Likewise, I'm going to do the same for my 126 gig LUN. So I can see I've got two replication sets. At this point, I can rename those based on any naming standards that I might have within the organization. In this case, we're just going to call them database and log so that we understand what those replication sets are. Click Next. Finally, what I need to do is assign the RecoverPoint journal capacity. So as we mentioned before, the journal is where we keep the historical block-based information that enables us to recover backwards and forwards through time with RecoverPoint. The amount of capacity you require for journaling depends on a number of factors, including your application write I/O for that consistency group, the granularity of recovery that you require, and also the time frame over which you want to actually recover over. So as an example, as part of a RecoverPoint policy, I could say, for this critical Oracle database, I want the remote site to be no more than 30 seconds behind the local site. I want a recovery granularity of every 10 seconds, and I want that over a 48-hour time period. And in this case, RecoverPoint and its rolling journal would enable me to recover back over that rolling 48-hour time period to that 10-second level of granularity. In this case, I'm just going to choose some capacity to assign to my RecoverPoint journal for this consistency group. So I can see now I've created the configuration of my consistency group. I can leave the Start Data Transfer Immediately box ticked. Click Finish. And I can see now I have this Oracle consistency group. So you'll notice that whilst we were creating that consistency group, we got a message about the volumes not being attached to the splitter. So in this case, I'm just going to attach those volumes to my splitter in New York. So I'm going to click Attach. Here we can see those Oracle LUNs. So I'm just going to attach those to my splitter. So now the Clarion knows that it's responsible for capturing that write IO and sending that to the RecoverPoint appliances for replication. So creating a consistency group, a relatively simple operation utilizing the wizards that are available within the RecoverPoint management application. So now what we'll do is we'll take a look at this Exchange consistency group. So the Exchange consistency group is replicating from London to New York. If we click on the New York site, I can see my journal tab. And what I can see on the journal tab is a sample list of points in time that we're able to recover back to. This is a sample list. This isn't necessarily the granularity of recovery that we currently have. We can explore right down to the nearest microsecond actually when we do a recovery. Okay, so at this point we're going to take a look at the Exchange consistency group. The Exchange group is replicating from London to New York. If I click on the remote site, New York, I can see my journal tab. Within the journal, I can see a sample list of points in time that I can recover back to within the RecoverPoint GUI. This is a sample list. This isn't necessarily the granularity of recovery that you actually have. You are able to add your own points in time to RecoverPoint. So maybe you're about to do an Exchange upgrade. You wanted to mark a point in time that you could recover back to in the event that there's actually an issue with the upgrade. I can simply click on Bookmark a Snapshot, and we'll just call this pre-upgrade. If I now take a look in New York, I can see now this pre-upgrade point in time that I could roll back to if I wish to. Anything that is a blank entry within the bookmark details is what we call a crash consistent point in time. So RecoverPoint, being a block-based replication solution, doesn't necessarily understand what's happening at the application level. So at the block-based level, we're creating what we would call crash consistent points in time, no different to switching off your application server, switching it back on again, and expecting that server to be able to recover itself. Obviously, customers also require application consistency. So we are able to create natively within RecoverPoint application consistent points in time, where we're leveraging technologies like VSS and VDI to actually quiesce the application before we mark a point in time within the RecoverPoint consistency group. So as an example, you may well see a VSS integrated point in time that looks something similar to this within the Bookmark Details tab, where you know that this is an application consistent point in time that you can recover back to. So we're going to take two scenarios. The first being operational recovery, i.e. I've had a corruption within my information store and I want to recover back to a point in time before that corruption occurred. And then we'll do a kind of failover from a disaster recovery perspective and then fail back scenario. So in this case, I'm running in my primary Exchange server in London. I'm only utilizing RecoverPoint CRR to maintain a replica of that data with a very fine granular recovery capability within New York. And I'm going to utilize that remote journal to actually recover my production LUNs in London back to a point in time before that corruption occurred. I simply click on Enable Image Access in New York. Three options: select the latest image. So this will be the least amount of data loss, but in this scenario where I've had corruption locally, that corruption will of course be mirrored to the remote site. I can select an image from that sample list that we saw previously. Alternatively, I can specify a desired point in time. So should you know the nearest microsecond that you need to recover to, or should your application administrator be able to tell you the point in time that they want you to be able to recover to, you can actually go in here and select the exact point in time, and RecoverPoint will give you the nearest point in time it has to that. If you've been running a journal and your historical journal information maybe spans more than a few weeks, you also have the ability to go and search on specific bookmarks within the RecoverPoint journal. In this case, we're going to use the selected image from a list. I click Next. I can choose any of these points in time that I want to recover to. For argument's sake, we're going to go back to this pre-upgrade point in time. So as an example, when I did my upgrade, I corrupted the information store. I now need to recover back to the point in time before I did that upgrade. I click on Next. I have two options at this point: physical access or logged access, and virtual instant access. In the physical or logged access mode, we will actually physically roll the historical block-based information from the RecoverPoint journal back onto the target LUNs to take the target LUNs physically back to the point in time you've selected. Once that operation is completed, that LUN is as it was at the point in time you've selected. That operation does not stop you from rolling backwards further or rolling forwards. The only constraint is if you're rewinding, let's say 12 hours, then you've got to replay 12 hours worth of data changes back onto that target LUN. With the virtual access mode or the instant recovery volume, as the name suggests, you can choose a point in time, and in this case, rather than physically applying the data from the journal to the target LUN, we'll actually construct something similar to a snapshot image within the RecoverPoint appliances and present that snapshot image over the SAN to the hosts. The nice thing about the instant recovery volume is if you don't know exactly what point in time you need to recover to, because you're trying to search for when that corruption actually occurred, it gives you the ability to very quickly choose lots of different points in time and test those. The downside of the instant recovery volume is in this case the read-write access speeds of that LUN are relatively slow compared with the physical access mode because you're reading and writing through the RecoverPoint appliances, and importantly, whilst you're carrying out these operations, RecoverPoint is continuing to replicate data from the source site to the target site. We're going to stick with logged access mode. I'm going to click next. We can see at the target site in New York that my storage is currently set to no access. The splitter technology stops you from actually stops the host from seeing any of the target LUNs unless they're paused at a point in time. So I've chosen my point in time. I click finish. You'll see this transition from no access to logged access, and you can see now that I am at this pre-upgrade point in time. At this point, I can do a rescan on my host or use one of the host-based utilities that comes with RecoverPoint to mount those LUNs on my host. That LUN will be at that point in time I've selected. If this was an application-based LUN at an application consistent point in time, I could test my application. I could see if the corruption was still there, or if indeed I've recovered back to the right point in time. If this was a database environment and we brought up a crash consistent point in time, it's possible that your database administrator may need to do some work to rectify any uncommitted transactions, as an example, on that LUN. That work can be done at this point at the target site to get that application back into a production-ready state. Once you're happy that what you have at the target site is what you want to recover the production LUNs to, I simply click on Recover Production. You'll see now the replication direction is reversed, and at this point we will copy the data from the journal, so the historical block-based information that we require to take the LUN back to the point in time that you've selected, plus any write IO changes that you've made whilst trying to make any remedial actions to that target LUN, as an example, from an application perspective. If this was a 2 terabyte LUN, we're not replicating the 2 terabytes. Literally all we're replicating back are the blocks that we need from the journal to take the target, or now the production LUN, back to the point in time that you've selected. In a real-life environment, what you'd see now is a point in time called synchronization complete. We're just going to add a point in time here for continuity called finished. And then all I need to do in London, click on Enable Image Access, choose that synchronization complete or finished point in time. Again, we'll see now that we'll transition to that point in time at the primary site. So those LUNs are again now available on the production environment to my Exchange servers. I can run up my Exchange environment. If I'm happy that everything has been recovered as it should have been, I can simply click the Resume Production button. And we'll see now that everything is reversed and my replication direction is now back as it was at the beginning. So I'm now again replicating from production back to DR in this case with only a few mouse clicks. The nice thing about the RecoverPoint journal functionality when doing a production recovery is the information within the RecoverPoint journal is maintained. So if I'd managed to recover to the wrong point in time for whatever reason, I can simply go back and repeat that recovery process to any of the previous points in time that are available within my RecoverPoint journal. So this is why RecoverPoint gets used very regularly for operational recovery as well as disaster recovery. So the second scenario is the disaster recovery scenario. So in this case, I've actually had a problem with my servers in London or my storage. I actually want to be able to fail everything over to New York and make New York my production data center. So in this case, what we're going to do is we're just going to pause the data transfer between London and New York, just to kind of signify that we've had a problem within London. And what I want to actually now do is fail everything to New York. So if you were utilizing Site Recovery Manager on top of RecoverPoint or Cluster Enabler on top of RecoverPoint, you could utilize those tools and they would make the necessary changes within RecoverPoint, choose the latest point in time, reverse the replication direction as required. In this case, we're going to do it manually within the RecoverPoint GUI. So again, I'm going to click on Enable Image Access. In this case, I'm going to choose the latest point in time for the least amount of data loss. You'll see now I've transitioned to that latest point in time in New York. And this time, rather than doing a recovery, I'm actually going to promote New York to be the primary data center. So I'm going to click on Failover to New York. I'm not going to start the transfer because at this point we're assuming that there's still an issue in London. And you can see now that New York is my production environment. So I would now bring up my Exchange infrastructure, if I hadn't done that already, within New York, and I would run my operations from New York. At some point in time, you're going to resolve whatever the issue was in London. Once you've resolved that issue, you can restart the data transfer. A number of different things will happen here dependent on what the failure situation was. If the RecoverPoint appliances within London have been up and running and have had access to the storage and have been able to track any changes, we will literally just synchronize the block-based differences that have occurred in New York and synchronize those to London. If my appliances weren't accessible or my storage wasn't accessible and we haven't been able to track any changes, we'll do what we call a partial synchronization. In this case, we'll read a section of disk at both sites, checksum it. If it's the same, we'll move on to the next section. If it's not, we'll replicate that block-based information across. But again, it cuts down the amount of traffic being sent across the WAN. If this was clearly a storage rebuild and the LUNs at what was my primary site are empty, then of course we'll do a full resynchronization between those two data centers. At some point in time, you'll get to a point where you're in a synchronized state and all you're sending over is the ongoing write IO. Then at a chosen point in time where you can take the application outage to switch everything back to normal, what you would do is shut down your applications in New York, mark a point in time in the consistency group, let's call it shutdown, so that we know at that point in time all my application services were shut down and therefore my application was consistent. And then simply all I need to do in London is click on Enable Image Access, choose that shutdown point in time, click Next. And now effectively I'm going to fail everything back to normal operations. So now I'm going to choose Failover to Exchange, London. So now what I've done is promoted London back to being the production source, and again now reverse the replication direction. I can run up my Exchange infrastructure in London, and everything of course is now being again replicated back to New York. Just finally, if we take a look at the Statistics tab, I can see a number of different metrics within the RecoverPoint GUI. I can see what my lag is at the remote site expressed via time or data. As an example, I can also see the bandwidth reduction that's currently taking place. I can also see overall what the application traffic is for that consistency group and what's being replicated across my WAN on a per consistency group basis. That concludes our tour of the RecoverPoint management application.